All right, today we're going to be talking about ratios and proportions. For the most part, this should be reviewed from Algebra 1. I will learn to write and simplify ratios and use proportions to solve problems. All right, and a ratio is a comparison of two quantities by division. And that's going to be something where we have A over B in fraction form where B cannot be 0. All right, so we're comparing two things and the second or the denominator cannot be 0. And there's three ways to write this. So an example would be writing it as a fraction, 3 to 4. You can also write it as 3, then the word 2, 4. And then the third way to write it would be 3 colon 4. Now, a proportion, it's an equation stating that two ratios are equal. Right, and kind of the general form for that is A over B is equal to C over D. Right, where this ratio on the left, A over B, is equal to the ratio of C over D. Right, and we call A and D the extremes, and B and C are the means. All right, so let's look at some examples, and we want to determine whether each pair of ratios forms a proportion. Now, to do that, we take the cross product. So I would multiply 4 times 16, and then I would multiply 6 times 12. And I want to see if they're equal. So 4 times 16 is going to give me 64, and 6 times 12 is going to give me 72. Right? And these are not equal, so then I would say this is not a proportion. All right, it is not a proportion. All right, so let's look at this next one. 1b, again, cross products. I'm going to do 3 times 10, which is 30. And then I want to do 5 times 6. Again, that's also 30. So I have 30 on this side and 30 on this side. They are equal. So then, yes, this is a proportion. All right, next set of examples. I'm going to show you that these are actually proportions because I do have the equal sign already. And we just have to solve for the missing part. In this case, we're looking for A. So we're going to multiply A times 4, which is going to give me 4A. And if I multiply 7.8 times 3.82, okay, that's going to give me 29.796. And if I divide by 4, that tells me that A is going to equal 7.449. Right. Now let's do this next example. Same idea, we're going to use cross products. The only difference with this is that I have a negative. Now I can use the negative with the 3 or I can use it with the 7. Either one, but as long as you use it one time. So I'm going to say negative 3x, I'm going to use it with the 3, is going to be equal to 7 times x plus 2. And we have to distribute this. So we get negative 3x is equal to 7x plus 14. If I subtract the 7x, I'm going to get a negative 10x equals 14. Divide by negative 10, I'm going to get a negative 14 over 10, which would reduce down to a negative 7/5. All right, these next two examples, 3a and 3b, I want you to try on your own, see what you get, and then you can check with me to see if you got the right answer in class. All right, this next few problems is going to be actual word problems. Don't freak out. This is just take it a step at a time. Mandy can read 45 words per minute. So my ratio is words over minutes. Okay? And so she reads 45 words in 1 minute. How many words can she type in a 25-minute period? All right, so my next ratio, I need to look at words over minutes. Since this is 25 minutes, 25 is going to go on the bottom, and the words is going to be what I'm looking for. That's my x. So we would cross multiply 45 times 25, which comes out to 1,125, and we multiply 1 times x, which is just x. So then my answer is she types 1,125 words in 25 minutes. That's the rate she's going. All right, next problem. Katie has a small bag of Skittles. She has 3 red, 10 blue, 35 purple, 8 green, and 7 orange Skittles. How many oranges would she have, orange Skittles would she have if she had a bag of 180 Skittles? Okay, this 180 Skittles, that represents the total number of Skittles. And we're looking at orange. Okay, so my ratio is oranges over total. And in the original, there were 7 orange. Okay, now for the total, we're going to add these up. You have 3 plus 10, 35, 8, and 7. Adding those together, you should get 63. Right. And then we have 108 total, or 180, excuse me. X would be what we're looking for. Cross multiply. 7 times 180 is going to give me 1260. Is going to be equal to 63x. If I divide by 63, we get that x is 20. So there would be 20 orange Skittles in a bag of 180 Skittles. All right, this last example of the word problem is I'm going to leave up to you. Example 6, in a local vehicle dealership, the ratio of cars to trucks is 7 to 9. If the dealership has 128 cars and trucks, how many trucks are there? I'm going to leave that for you to solve. All right, this last little bit, we're going to use some more Algebra 1 review. This is direct variation. If you see the phrase y varies directly with x, that just means that y is k times x, where k is some constant. And in other words, that's just going to mean that y is a multiple of x. So there's some number that I multiply x by to get y. Okay, let's see. Example 7, y varies directly with x and y is 84 when x is 16. What's the equation that best represents this situation? All right, so remember the general formula is y equals kx. Okay. Y is 84, so I'm just going to substitute 84 equals. K is my constant that I don't know yet, and x is 16. So 84 equals k times 16. Kind of just standard notation, we would write 16k. And that's going to be the equation. You can solve this, but the problem just says, what's the equation? So I would stop there. All right, let's look at this last example. The amount of chlorine Y needed for a swimming pool varies directly with the amount of water X. So there's that varies directly. To fill the pool, if 16 units of chlorine are needed for every 125 gallons of water, what equation best represents the situation? So again, it's very directly, so we're going to use that y equals kx. Y represents the amount of chlorine, and there's 16 units. So I'm going to have 16 is equal to k. And then the x is the amount of water. So that's going to be 1,250. And again, I'm just going to rewrite it so it looks like standard notation. And it asks us for the equation, so that would be it. All right, I just made it right in time for the bell, so we will see you in class.